In this tutorial, we're just going to look at the Avogadros constant practice questions, even as we proceed to talk about other concepts. Okay, so question 1 says, calculate the number of molecules in 3 mole of propane, the number of atoms in 0.25 moles of ethyl methanoate, ammonium ions in 100 mole of ammonium phosphate. Okay, so in case you don't know what the Avogadros constant is, the number is 6.022 times 10 to the power 23. Okay, so this number is going to be very useful each time they ask you to determine the number of molecules, atoms, ions, whatever they can get to ask you. What I want you to take note of is, whatever they ask you, the units are per mole. Okay, so if we write it down mathematically down here, 6.022 times 10 to the power 23. So what that means is, if they're asking you, for example, question 1 is asking about molecules, right? So we'll say molecules and then over the mole. So from this, you're able to see that each time you want to determine the number of something, you need to multiply by the number of what? Mole. So that the moles can go and then you get your units there. Okay, now there are some modifications we have to make to certain questions. So starting with question 1, calculate the number of molecules in 3 mole of propane. 3 moles of propane. Okay, so 3 moles of propane. Of course, you know that propane is an alkane, right? With the general formula that. So propane is expected to be C3, and then if you put a 3 there, 6 plus 2, that's 8. So how many molecules of these are we going to have? So the way it is existing like this is called a molecule for any information. Okay, so therefore we just need to multiply by the number of moles, right? So number of moles we've been given in the question are 3 moles. So 3 moles. So if we basically get to multiply the Avogadro's constant, we have multiply by 3. So grab your calculator and try that one out. So the answer you should get is 1.8066 times 10 to the power 24. 24 what? Molecules. Okay, of propane. Now this same question can be rephrased, as we will see in the next question, where they can ask you to determine the number of atoms in 3 moles of propane. So in such a case, if you look at this molecule of propane, how many atoms are there? We've got 3 plus 8. That would give us 11, right? So that would now involve us multiplying by 11, since we'd have 11 moles of, would have 11 multiplied by the 3 moles of the atoms being produced. Now let's look at the next question. So the next question says, calculate the number of atoms in 0.25 moles of ethyl methanoate. So here we are trying to determine the number of atoms. So atoms, don't forget the unit is per mole. So ethyl methanoate, what's the formula for methyl methanoate? So the formula is C3H6O2. So as a molecule, if it was a molecule, we're just going to multiply the given number of moles. Okay, now in this case, atoms. So this is a molecule. Now how many atoms are there? So 3 plus 6, 9 plus 2, that should be 11 as well. So you have 11. 11 what? 11 atoms. Okay, so if we look at what we have now, this is a case where you now come up with an equation to say, okay, we have 11 atoms being produced per every molecule. We have 11 atoms. So if you've got 0.25 moles, it means on the atoms it's supposed to be by 11. Or to avoid that complication, I can just go direct by saying, okay, we multiply the Avogadro's constant against the number of moles given, 0.25 moles, okay, So that is 0.25 moles per molecule, right? The molecule of what? Methyl ethanoate. Now, what we want to determine is the number of atoms. So, how many atoms are they being produced? So, we actually have 11 of them. Okay. So, the atoms is already there. Yeah. So, we have 11 there. So, I think that's the only difference. That's the only modification we can make. So, I can remove that. Unless maybe if we could have said, okay, well, we know that the Avogadro constant will help us determine the number of molecules. Per every molecule, we are going to have 0.25 moles. Okay, that's per molecule. Now, in this case, we are dealing with 11 atoms per each molecule. So, in this case, the number of molecules would go, and then the moles will go, so that we just remain with the number of atoms there. So, grab your calculator. So, the answer I'm getting is 1.66 times 10 to the power 24 atoms. It's that simple, right? It's very, very simple. Just pay attention to the small things there. Yeah. And then finally, C tells us we need to determine the number of ammonium ions in the 100 mole of ammonium sulfate. So pay particular attention to this one. So if you feel confident enough, feel free to pause the video and just try out this one. So we have NH4 3 PO4, and then we have, so this is the formula for the ammonium phosphate. Now they want us to determine the number of ammonium ions. So if this gets to split, we're going to have 3 ammonium ions plus a phosphate ion. Of course, take note of that. So the formula is very easy to predict by knowing the fact that ammonia is NH4 with a positive and then phosphate with a 3. So you know how to come up with the formula, right? So just swap the valences there. So from here, you're able to say for every mole of ammonium phosphate, there are 3 moles of ammonium ions that are produced. Now in the question, we are told 100 moles of ammonium phosphate. So here we have 100 moles. We don't know how many moles of ammonium ion we're going to have. Well, since they're in the ratio of 1 to 3, we can cross and multiply. So we are also going to get, if per mole we have 3 moles, per 100 we're going to have 300 moles of ammonium ion. So that saves you a bit of some work already. Now what do you want to do? You want to determine the number of ammonium ions. So you've already determined the number of moles by using the mole ratios there. So you can just use the Avogadros constant straight away. 6.022 times 10 to the power 23. So we've already determined what? The number of ions. So ions per mole. And then we multiply by the number of moles, 300 moles. So multiply there. So the answer I'm getting here is 1.8 times 10 to the power 26 ions of ammonia. Okay, so that's how you answer these questions. So there are more questions coming up. Question 2. Calculate the amount of a number of moles, in other terms, of aluminum oxide that will contain 2.63 times 10 to the power, this was supposed to be the power 28. So 2.63 times 10 to the power 28. oxide ions. Okay, so we need to determine the number of moles of aluminium oxide. Now the formula here is Al2O3 for aluminium oxide, giving us 2 aluminium ions plus 3 oxide ions. Okay, so what are we saying now? Calculate the number of moles of what? Of this guy, aluminium oxide. So we need to determine the number of moles. That's the question. That will contain 2.63. So we're given the number of oxide ions. 2.63 times 10 to the power 28 oxides ions. So here the funny part in this question is we are already told the number of ions that were produced, and those number of ions are of what? Oxygen. So we can come up with a formula. We know that each time they want you to find the number of something, it can be number of ions, number of molecules, number of atoms. We know that what we do is we multiply the Avogadros constant, okay, against the number of what? Against the number of moles. That's one thing that we know. So per mole. So in this case, we're dealing with ions. So multiply per mole, and then we need to multiply against. We need to multiply the Avogadros constant against the number of atoms that we are dealing with, or the number of ions. In this case, we deal with a number of moles. Sorry, we multiply by the number of moles so that this part can actually cancel out. That's what we basically get to do. Now, if you check in this case, we don't know how many number of moles were used to multiply, so we'll put X there. But we know on the other side to say the number of ions for the oxide we are given to be 2.63 times 10 to the power 28. So it's like this question, what we're doing is the opposite of what we are from doing previously, because in this case you are given the number of ions in advance. So instead of multiplying as before, we are going to divide so that we get the number of moles of the oxide ion. So our value of X is going to be the 2.63 times 10 to the power 28 we have. 2.63 times 10 to the power 28 as the number of ions. We need to divide by the Avogadros constant right away, so that we basically get the number of what? We get to get the number of moles of the oxide ion. So 2.63 times 10 to the power 28 divided by 6.022 times 10 to the power 23. So the value I'm getting is 43,673.198. So these are the number of moles of the oxide. Now, in the question, they want us to find the number of moles of aluminium oxide. The reason why we found the number of moles of the oxide is because the number of ions we were given were for the oxide. So we've dealt with oxygen. Now, if you check the aluminium oxide against oxygen, you will notice that they're in the ratio of 1 to 3. What that means is per every mole of aluminium oxide, we have 3 moles of what? Of the oxide ion. So you can come up with the ratio. Okay? So you know that they're in the ratio of 1 to 3. So here, how about here, what are we going to find? If you cross that multiply, you end up dividing by a 3. So dividing by a 3, the answer I'm getting is 14,557, yeah, 0.7 moles of aluminium oxide. Now, if I was going to follow certain rules of chemistry, I know that I'm supposed to get 3 significant figures, which will give me 1, 4, and then this will give us 6. So you end up 1,4,600 moles. Yeah. So basically this is what we have for this question. Question 3. A mixture of tetrachromethane, which is that, and trichromethane contains 0.1 mole of hydrogen atoms and 0.5 moles of carbon atoms. Calculate the number of moles of chlorine atoms in the mixture. So let's try to understand the question together here. So what we are told here, or what we have is, we have tetrachromethane being mixed with trichloro, so which is possibly, now I feel here there should be a hydrogen for the trichloro, since we expect carbon to form up to all the way up to four bonds. Okay, so for the other one, all the four were substituted. Yeah, so that's why we need to have a hydrogen there. So CHCl3. Okay, for this part. So this mixture, we are told it has 0.1 moles of hydrogen and then 0.5 moles of carbon atoms. Now we need to calculate the number of moles of chlorine. That's the question. Okay, so let's come up with a relation here. So say let's take anything coming from this side to be x, and then anything coming from the other side to be y. So we'll look at, first of all, carbon. For each, we have a single carbon. So for the first one, we'll say x. For the other one, we'll take it to be y. So we'll put a coefficient of 1, 1 because there's only a single carbon in each. So this is equivalent to 0.5 because we've got 0.5 moles of carbon in the mixture. The other relation we can come up with is on the hydrogen part. So we only have a hydrogen in one side. Okay, so this side where it's coming from, we've got a y. So y is equal to 0.1 for the hydrogen. That tells us that all the number of moles of hydrogen we have in the mixture are coming from trichromethane, because that's the only part we have the presence of hydrogen. Now for chlorine, in the first one we have got 4, so we'll take it to be 4x. And then in the other one we've got 3, so we take it to be 3y. So this is going to give us an answer, right? Okay, so in case you didn't get it, so I said let x denote this part, y denote that part. For the first one, we consider first of all the number of moles of carbon, which is 0.5. So we had a coefficient of 1 and a 1 on each because we only have a single carbon in each molecule. So x plus y should be give us 0.5, since we've got 0.5 moles in total. And then for the second one, we only have y because hydrogen is only found in one molecule, which we are denoting by y. And since we only had a single hydrogen, we are taking it to just be 1y, which is just a y, and then equivalent to the number of moles of hydrogen atoms, which is 0.1 in the question. And then we have come up with a final relation, which is now denoting the number of chlorine atoms. In the first one, we've got 4. In the other one, we've got 3. Of course, adding the respective variables that represent them. So here it's going to give us an answer if we find the value of x and y. So the value of y is, do we already have? So we can substitute in the first equation. So x plus 0.1 is equal to 0.5. X becomes 0.4. So we can substitute in the final equation 4 times 0.4 for the x, and then 3 times 0.1 for the y. That should give us a final answer there. So grab your calculator. 4 multiplied by 0.4 plus 3 multiplied by 0.1. So I'm getting a value of 1.9 moles of chlorine. Okay. So let's proceed and look at the mole calculations.